rings on the table. Now, if I told you that there is a force of attraction, I have an exercise where you will calculate for two objects of the same mass.
Okay.
Yep. Let's put these two rings on the table. Now, if I told you that there is a force of attraction between those two rings, you would probably say, no way. But there actually is. It's just a very, very, very weak force. In fact, we call it the weak force in physics and science. We call it the force of gravitation. The same force that brings you back down to the floor if you jump up in the air. The difference is that these are very small objects with very, very tiny relative masses. In other words, the amount of material in them is minimal. Now, the bigger the object, either object, the greater the force. So one can understand how we could experience the force of gravity because of the mass of the Earth and the fact that we're very close to it. Now, if I move these closer to each other by a factor of 2, the force increases by a factor of 4. This is called an inverse square relationship. If I double the force and double it again, it would be 1/4 the original force that we saw.
Okay, now if you can imagine these two rings as being magnetic, you probably have experienced playing with magnets that as I move them closer together, they actually move together. There's actually a force manifests itself in accordance with Newton's second law into an acceleration and a displacement. Now, but if I move them as close as I can together, I really can't get these two objects to come together on their own. And that's because the gravitational force is so much weaker, trillions of times weaker, than the electrostatic or magnetic force, the electrical kinds of forces. So we call those the strong force. And indeed, if were it not for the strong force, you could walk through walls. But it's the electrostatic force. It's not the solidness of the wall because it's mostly empty space, as are you, as are most everything. And so you could walk through walls were it not for the electrostatic force.
I have an exercise where you will calculate for two objects of the same mass, okay, and two different charges, the force acting between the same distance, same relative distance between the two objects. And that will demonstrate to you just how much greater the electrostatic or strong force is than the weak force, the gravitational force. Let's put these two rings on the table. Now, if I told you that there is a force of attraction, I have an exercise where you will calculate for two objects of the same mass.
Okay.
Yep.